With this animation, I would like to give you an idea of the treatment plan, of the treatment goals that we have for this complex patient. We have divided the treatment in two main stages. The first stage, which is this one, where I want to expand the second quadrant. You can see the movement in the frontal view. And you can see the same movement in the occlusal view. This way we are creating some space to move the anterior teeth. At this point, when we have enough space, we can start moving the anterior teeth in this way. This will create space distal to the first premolar for an implant, and will create overjet and will roughly align the midlines. The same movement can be seen in the frontal view. And as you understand, this is not just an inclination of the teeth, but we need to move the roots, and there is a big part of translation in this kind of movement. The software is able to help us in finding out an approximation of the needed force vector in 3 dimensions. And here you see the different parts of the software that's making this calculation. Now let me describe it. Here, this black line that you see here is what we call the axis of rotation. This rectangle here, a little bit darker, represents what we call the plane of rotation. And the plane of rotation is constructed starting from the axis of rotation, which is determined by the movement, and the position of the CR. So we create a plane in this way. So in other words, we can rotate it and see that actually the axis of rotation is something like this. Okay. Now, there is another plane that we are interested in too, which is what we call 2D plane, where actually you can simulate, and here it is, our movement and our vector calculation as if it were a two-dimensional problem. So this is it. But actually, finding these two planes is essential for us to determine finally the vector in 3 dimensions. Anyway, we cannot go too much in details, and I just want to show you how the force vector is represented in 3 dimensions. Here we can, of course, rotate the models and see the force vector in all directions. Okay, so as you see, now we have a 3D representation of the needed force vector, and this is probably the main goal of our project, to find out in 3 dimensions the needed force vector, although of course there is some approximation for it. In this animation we can see the representation of the same force vector that we have determined before by moving the teeth. As you might see, this vector is not actually in a position that can be reached by our appliance. So if you look at it in 3 dimensions, it's out of the working area in our dental arch. So in order to obtain this force vector, we need to work a bit and make what we call a calculate and design a two-vector mechanics. So first of all, we have to calculate the two vectors that we need. And we do this by choosing first 2 points where the two vectors will be applied. Here's the first point that I have selected, which is at this level, more or less at the bracket that we will place here on the first premolar. And once you have placed this point, the software creates a plane that is connecting this point with this vector line. And the second point must be laying on this plane. So we have some limitation. So here is the second point that we have selected in this area here. Actually, this is a mathematical construction, and you will see that I did not follow, in my case, exactly this combination of 2 points, because actually at those time I didn't do this evaluation in 3D. So with these 2 points, the software can calculate 2 vectors that you see represented here in red and green that combined together will deliver this force here. Now these 2 vectors, let me do this, are represented like that in this plane, but if you see it frontally, they have a completely different orientation. You might decide to change this angulation because there is an infinite number of couples. So for example, we can make the green arrow completely vertical and is more sagittal, and so on. All this combination deliver the same result. Now we have seen a sequence that has led us to design, or at least to have the background, the base to design a proper mechanics, a proper rational mechanics to obtain a specific movement. We have simulated the movement. We have estimated the needed force vector for this movement. And since this force vector was not obtainable directly because its point of application, the line of application, was out of reach, we have replaced it with these 2 vectors applied in these 2 points, where we can actually apply our force through our appliance. So thank you.